I guess I can move my mouse off the middle of the screen. So the caveat here is that every time I give a talk, as will become apparent later, I have this philosophy of using very simple tools that do exactly what I need and nothing more. So this presentation tool I'm using is called Send. It's like 1,000 lines of C code, and it uses the raw xlib bindings to just take single lines of text and blow them up as big as possible as will fit on the screen. And I'm trying it out, so thank you for being my unknowing guinea pigs. I've been testing it, and it seems to work, so we'll call it good. All right, so the title of my talk, according to your program, is This Will Be Easy, or It Will Be Easy, with a subtitle of The Trials of Updating a Product from Python 2 to Python 3. But really, what it ought to be called is How We Fixed a Bunch of Wrong Decisions That I Made a Long Time Ago. I work as the CTO and a co-founder of this company called Barrio. And what we do is inventory management and usage and price point forecasting for food businesses. So, given my current sales over some time period, what should I expect to spend on flour at my bakery in the next year or the next 3 years? And we ingest a lot of commodities data and things like this and try to come up with smart extrapolations. But on the surface, all we really do is count things coming in and out of your pantry. Our technical stack, so Barrio has been around. The very first version of code, like in git commits, I can trace the history of our code back to code I wrote that runs on an Apple II, like today in my workshop. I have a lot of these old computers, and I like to do things with them. So I have an Apple II that runs my HVAC system in my workshop. It runs my electronic door locks. It also keeps track of all my resistors and capacitors and things like this. And this is all AppleSoft Basic with a custom expansion board. It's really cool, like geek cred, right? This works great, and it has worked great for a long time, except my workshop got struck by lightning. And because of how I had, just kind of cobbled this together, my Apple II just and was no more. And it's really, really hard to find ROM chips for Apple IIs, Apple II Pluses, which is terribly important since the basic interpreter is baked into the ROM. So suddenly I couldn't even get into my shop because now my, my electronic door locks won't open, and I had it so that they failed closed and things like this. So back to this, a series of bad decisions. So while I waited to find another Apple II that I could pull ROM chips out of, I decided, well, maybe it's time to do something a little bit more modern. And so I rewrote my inventory tracking software, which was very rudimentary, in Python. And it ran on a Raspberry Pi that just kind of sat on my desk. Actually, it probably sat right on top of the Apple II, maybe with a little bit of cardboard in between or something. But at the time, I had only ever used the web framework for Python called web.py, which was originally written by Aaron Schwartz of RSS, Creative Commons, early Reddit days fame, and later many other things, which is a great framework, and it served its purpose super well. It fit my design ethos of a very small tool that did exactly what I needed and nothing more, and it was great. And it took me, I don't know, maybe a weekend or so to re-implement from AppleSoft Basic to modern Python 2.7, my inventory tracking solution. And around that time is when I met Karen, who would later become my co-founder at Barrio, and we realized that there was, in fact, this need for food business inventory stuff. And since maybe you can't really use a Raspberry Pi sitting on top of an Apple II in your workshop, As a production server, we moved it to web.py on a real server, which basically was just me cloning the repo elsewhere and spinning up Nginx on a VPS. But it worked, and that served us well, very well, for a long time. If you can ignore the Scott Adams and his philosophy, I think Dilbert speaks well here. So like, this is the epitome of legacy code, right? I mean, it started with AppleSoft Basic. So this is Microsoft Basic licensed to Apple. AppleSoft Basic, that was written by someone who was not even born when the Apple II Plus was around. And then like ported forward and just hacked together, and when it would crash, it'd be like, oh, well, I'll just unplug the Raspberry Pi and plug it back in, and it'll work until it hits like that index error again or whatever. It worked fine, but it was terrible. Yeah. So as Barrio grew and got more customers and paying customers who expected things to actually work and not crash, a couple times a day, we started thinking about these things like, let's write a client library or an SDK. I need to advance my notes. Sorry. Emacs is failing me at the moment. So we wanted to write a client library, SDK. I really wanted to do WebSockets support from the server because we have a web app and an iOS app, but they both relied on fetching from a REST API, and it would be really cool to just be able to do things where like I've got my my front end point of sale system, and as I make sales, like my produce buyer who's out at the market just like gets the real-time updates instead of them having to like ditter-dotter along around in the web app or in the mobile app to force updates. And I couldn't find a good way to do WebSockets using web.py. And the more I looked into it, the more it seemed like it was really the fact that we were stuck in Python 2.7 land. Maybe that's just my FUD or my terrible Google searching skills, but last year at PyOhio, I was really excited because I spent some time at one of the sprints, and I actually was almost successful in porting web.py to Python 3. I got it so all the tests passed, but as soon as you started or tried to start a WSGI server, it would just barf everywhere. And so it's like, all right, well, maybe we'll switch to something else. Also, Python 2 is end of life in just over 3 years, and I really hope that Barrio is still going. And it would be really a point of shame if our production code relied on something that was end of life. So like I had all these thoughts going on, and I'm still getting paged in the middle of the night for crashes and just like weird behavior. And they've been getting fixed, don't get me wrong, but there's lots of stuff that's going on here. So we needed a plan going forward. And this was becoming very, very obvious very quickly. And I knew that this is already the second time I had rewritten this code base. I was not going to rewrite it a fourth time. I'd rewrite it a third time if need be, but I would not do it a fourth time. So the whole plan was, let me just figure out this best path forward, and then we'll do it, and we're sticking with it no matter what. Because I'm tired of like dealing with all these regressions every time you switch languages or frameworks or anything. So the first thing that I did was I started looking at, all right, I like web.py because it's a minimalistic web framework. And if you Google minimalistic Python web frameworks, I think Flask is probably the first couple pages of hits. And Flask is good. I've never used it. People speak very highly of it. I've looked at examples in it, and I couldn't bring myself to do things that way. Like I said, I have this particular set of doing things. I mean, here, I'm a guy who likes to write modern things on old machines, and I just couldn't bring myself to write anything in Flask. So I looked at other frameworks. Twisted is event-driven, and it was not obvious to me how to do REST HTTP verb-based things using Twisted. There was something called like T-Rex Twisted or something like that, or T-Rex REST, something that was a way to do RESTful kind of stuff on Twisted. But again, like, it just seemed like we were gonna, if we went this route, we'd end up again at another place where 8 months down the road, 18 months down the road, be like, well, crap, well, let's just switch again. Like, and I didn't want to do that. I've used Django before for things, and it really seemed like it was probably overkill for what we needed. Because like I said, we have a web app and an iOS app, and basically all they are thin clients for our JSON REST API. So like, we don't need anything except a way to ingest JSON, deal with the database and some other peripheral things, and like spit back out JSON. And then I recalled that from poking around in the web.py codebase, the WSGI server class implementation from web.py was wholesale copy and pasted out of an earlier version of CherryPy. I don't remember which version of CherryPy, but I mean, like literally the whole folder structure was just plunked in there, and yeah. So I was like, oh, hey, maybe this is an avenue to go down. And then it turns out that the more I read about CherryPy, the more I saw that, okay, people are actually using this to do very successful things, notably Netflix, Hulu, Sickbeard, SAB-NZBD, if you're into using that for binaries, things like that. And so like people were actually using it for real things, and it was working for them. And it's really mature. It's been around for at least 10 years. So that's a long time. I mean, not as long as the Apple II, but still, it's a long time. And so this was great. I was like, oh, perfect. And it seemed like it was going to be very obvious how to move the web.py-based code to being run under CherryPy. And so this was the forerunner. Once I made the big list of like, here are the different frameworks, CherryPy was a very clear winner. This is an appropriate time for a small aside. This is a really, really good blog post, and I would suggest you all read it. My takeaway from here is that if you have a technically hard problem, you should use very boring technology. But if you have a really boring problem, then use whatever tech you want, be it fun and exciting and clever stuff. And this is you can agree or disagree with that statement however you choose. Being that Barrio's code base is my baby, it was like, oh, great, we've got a technically hard problem. And on the surface, counting like cucumbers in a fridge or counting pounds of potatoes, in a walk-in, it doesn't seem very hard, but as soon as you like talk to a baker, like, oh my God, how do you do this? Like, how do you do this every day? So if you consider flour, you buy, even in your own home, you go to the store and you buy a 5-pound bag of flour, but all of your recipes use it as cups. And, so there are lots of things like this where you're buying it by weight or mass and using it by volume, and they have a non-standard density, to the point where if you go on King Arthur Flour's website, they have a giant table, and it shows you every kind of flour that King Arthur makes worldwide, and they show you, here's like your minimum density that you should expect, here's a maximum density, here's an average density. I think they even give you like confidence intervals on those. It's like, no baker is ever going to like be like, oh, hey, am I gonna get 14.783 cups or 15.3334 cups out of this 5-pound bag of flour? Like, they don't care. They wanna know how many donuts it's gonna make. And so this is a really technically hard problem. So from the onset, and still today, we try to choose technology that's boring in the sense of like, make it work and make it so that like when there is a problem, we can go in and say, oh, well, this is because of how like floating point numbers are implemented in C, or something stupid, like, which is a real problem we've actually had. All right. So at the time that we were making this decision, we had roughly 100 daily active customers. So this is like 100 bakeries actively putting in or using ingredients out of their barrio pantry or food trucks. And we couldn't break anything. I mean, that should be a general statement anyway, whenever you do an upgrade or an update to your system. But like, here we had food trucks, and from my semi-insider knowledge of the economics of food trucks, if you lose a day or two of revenue, you're probably done. Like, they operate on insanely slim margins. And so it was unacceptable for us to make this upgrade incur any downtime whatsoever, to the point where, because these were such huge changes, and because the app review process for iOS apps does take a couple days, it was also unacceptable if we changed at all the JSON output of any of our API calls. So our saving grace there is that the order of keys in JSON is not, does not matter. So as long as you have all your keys there, it's fine. But we needed to make sure that we never ever, like if we were returning, for the key items, if it was an array of other objects originally in the Python 2 version and the Python 3 version, it still better be the key items and then an array of inner objects. Mostly just to make sure that, I keep my apps on my phone pretty updated. I'm sure all of you do too, but if I look at my father's iPhone, it's depressing how many app updates there are for even apps that I've made for him. So, our users aren't technical people. So, even sending our customers an email saying, hey, you should really update to the newest version of the app, no one does it. We've even turned off versions of the app, and like people call and say, hey, my iPhone stopped working and now I'm at the Apple store. Can you please help me? Oh God. So luckily, from the very beginning, we were using Runscope, which I believe used to offer a free tier, and now I think it's only paid tiers. But if you use Runscope, and I would suggest that you at least look at it, you can specify network requests, API requests, and then and then ensure that the return value has particular bits in it. So for our case, we were using it from the get-go to make sure that if I add 5 pounds of flour and then I use 3 cups and it's this brand, I should expect that I have 13.88 whatever pounds left. We were doing it kind of, I don't want to say in lieu of unit tests or functional tests, but that's probably closer to the truth than anything else I would say. As long as our API was returning things, since all of our clients referred to the API as the absolute source of truth in the world, as long as the API was functioning, everything in our whole ecosystem was working correctly. So the follow-on to this is that because we were using Runscope from the beginning, and because it was unacceptable for us to change any return structure, we had a full history of what every single HTTP verb for every single API endpoint for every resource, we knew what that structure was, and we had a very clear way to make sure that we weren't changing it. We had it, I think it's still set every hour. We hit every single one of our API endpoints for every HTTP verb that endpoint supports, and get successes and failures and things like this. And so we would know, within less than an hour of pushing an update if we had changed that structure, because now our Runscope test would not pass. So this was an invaluable tool for us, and I really think that it saved us a lot of headache. It was kind of a pain to set up at the very beginning, as you might expect, especially because I think I spoke here last year about cores, and as a corollary, I kind of mentioned that as long as your client and your server both know how to handle a given HTTP verb, you can make any verb you want. I think that's kind of funny. So we have special HTTP verbs that we use internally in our app to do things, which is not a great idea, but it was like a weekend hack that kind of persisted like everything else. And it's actually worked out really well for us. So like you can send an HTTP verb of confirm SMS, and as long as you're sending the right other headers, it'll actually like re-trigger the phone number activation flow and things like this. So like it's useful for our support people to help our customers when they have issues. It also saved me having to build an admin tool. I could just give them buttons to click and it would issue curl commands. And that was a very big time saver. I mentioned our comprehensive set of return JSON. And all along I'm thinking, all right, this will take like a weekend. I wrote all this code. I still have it all in my head. I know how all the moving pieces across the whole architecture work. Should be great. And I remember giving the stand-up status of, yeah, so I think this weekend when my wife and daughter are visiting my in-laws and I'm at home, I think I'm gonna do this. And I think that come Monday's stand-up should be fine. And if all goes well, you'll never even know that I did this unless you start looking at the commit history. Because if it is working correctly, there should be no API degradations. Customers, it should be transparent to everyone. No. I suppose this was kind of a giveaway if you read the description. I think in total it took us almost 4.5 weeks, and there were a couple times where there was a discussion about, is this even worth it? How big of a deal is WebSocket support really? But in the end, it has worked out. So once we had made our decision of what to do, now the whole point was, how do we get there? So web.py has this really nice to use database wrapper class. And it gave you named tuples when you would say things, db.select from this table, here's my little query. It would give you back named tuples. And that was super handy. We didn't know what to replace it with. And so first, we looked at MySQL DB and said, okay, this can kind of work, but I like having options. And then I found MySQL.connector, and I really liked this a lot better. I mentioned that we have run into some problems with C interop stuff. We do have parts of our stack that are in C, and so being that MySQL connector has a Python and a C API, it was handy because I knew that, all right, this is just one dependency now instead of a couple things. So we ended up going with MySQL.connector, which was great. And it was perfect. So originally, I don't know has anyone ever used this library? It's really kind of interesting. It's, the documentation for it is hosted by MySQL, and I think it's the official, MySQL official Python bindings. But there's this class called MySQL cursor. And if you look at their documentation, it's oh, you make a cursor object, and then you do this cursor.execute and give it a SQL statement, and it'll do it. That's great, except when you start running into problems and you can't figure out what's going on. So in a fit of frustration, you actually go and download the source for this library and you start looking through it, or maybe actually read the documentation and go, oh, look, there's something called MySQL cursor buffered. Notably, the one on the right here buffers the output, and so it's useful if you're doing many small queries in succession. This was I think it took me a week to make that jump of like, why isn't this working? And like rewriting things, and I couldn't get it to work. And then MySQL buffered and it solved my problem. It's like, oh, perfect. So if you recall, web.py, their database wrapper gave us named tuples. MySQL cursor and MySQL cursor buffered give tuples. So in lots of places, well, any place I was fetching things out of the database, I was doing like, row index 0, and then I'd have to go and actually look at my MySQL table definition, say like, oh, look, the index 0 is the first column. And like, that just felt wrong, but I couldn't fathom a way around it. And at this point, I was just happy that I was actually getting things out of my database. I really didn't care that I was using hard-coded indexes everywhere. So then I found MySQL cursor dict, which returns a dictionary for each row, where your keys are the column headers or column names, and then the value is your value for that column for that row. And that was awesome. And then I very stupidly made the same mistake I started using MySQL cursor dict instead of MySQL cursor buffered dict. And quickly realized my mistake, but still, like, that was maddening in retrospect. There's a lot of headbanging about that point. So this is the line that I think is absolutely terrifying. So here, every cursor class has an execute method, and they take 3 parameters. The last 2 are optional. The first parameter is a string of a MySQL operation to do. So, like, oh, cool, I can make a SQL statement into a string. So you do something like this. I guess this is where this display thing fails. So if you can see here, this is all in the first argument. I've got a string, and I'm just like, hey, give me all my users where the name is like, and then here's some like contrived post data name field. This is really, really scary, because it would not take someone too malicious to realize that, oh, well, let me just put in some nasty MySQL thing in here and post it as my name field, and suddenly, you're dropping tables wherever you want and things like this. So I remember writing things like this, and then I thought, oh, this is a really bad idea. Like, this is silly. Maybe we should have gone with MySQL DB. Until I, again, looked at the docs, and then it turns out that if you pass in your string with wildcards in it as the first parameter, and then all of your data as a tuple for the second parameter, what ends up happening is this execute command, if you follow it all the way down the call stack, it sanitizes, it quotes things as need be, and it also does super fancy things like converting datetime objects into things that can actually be put into MySQL datetimes, and it does this auto-magically for you, which is really cool. So I just think that the missing comma there, these lines are identical other than the comma, and that's a huge thing. And it's not obvious because they will both work, unless there's a typo in that MySQL. They'll both work, but one of them is wrong, and one of them is less wrong. The other question was, all right, so now we have a functioning Python 3 Cherry Pie application. How do we deploy it? So before, we were using Nginx and running our WebPy application under a little WSGI server thing and doing all this magic, and this was fine. But I didn't know how to deploy a Cherry Pie thing. I had never deployed Cherry Pie. I'd never used Cherry Pie. And the docs weren't super helpful because the default example when you click on deploy in the Cherry Pie docs is, oh, Cherry Pie has its own built-in server and allows you to just run on any port you want. So here's an example of spinning up a Cherry Pie server on 3 different ports on the same host. That doesn't tell me how to deploy it to production. I don't trust Cherry Pi's built-in server to handle, production loads. So digging around through the docs there, and maybe this is all just FUD, but this was my own experience with the Cherry Pi docs. So then, like, oh, cool, Cherry Pi can run under WSGI stuff. And then a little farther down, it's like, oh, wait, why not just use Nginx as a complete reverse proxy? And then you can also use Nginx's built-in load balancing, and you kill two birds with one stone. And that was kind of the aha moment of, oh, like we've cut out a fair amount of just infrastructure and like passing things around internally between what we used to be doing, and now it's just Nginx and proxy pass, command block. But then the issue is, all right, so now I've got logs, but because I'm using Nginx as a reverse proxy, in my logs, every request is coming from my own IP, in my Cherry Pi logs. Because as far as Cherry Pi is concerned, every request that it gets is coming from the Nginx process that's running on the same box as it. So there are two handy options in Cherry Pi where you can turn on these proxy tools and you can set a base origin. And if you do this, now suddenly all of your logs have the real IP and things like that from your actual request and not the one that's coming from Nginx. So that's where we got. And we had this legacy system, super legacy system that I knew the ins and outs of, but no one else did. And it has worked. And now we have other people besides just Karen and myself working on Barrio, so it's even more important that I'm not the only one who knows how things work. The takeaway out of all of this, in retrospect now, looking back, our web.py based API server application, whatever you want to call it, maybe due to a limitation of my own Python knowledge at the time that I first ported my AppleSoft Basic to, or maybe because of just poor choices. We originally had a model.py file and a server.py file, and that was it. And so all of our everything, if it wasn't putting things into or out of the database, so like all of my MySQL commands and things like this were all in model.py. Everything else was in server.py. And maybe you saw beforehand, but I used like this little tiny netbook that's hacked together and cobbled together. And it got to a point where like Emacs would start crashing when I'd try to open up our server source. Now we have one file per resource, and it's fantastic. So there's like ingredient.py and recipe.py and sale.py, and it makes it way more maintainable. Mostly because our new developers, they don't have to go, oh, I wonder what Zach called this class when he wrote it 5 years ago, to figure out like the class for an ingredient that's associated with 2 recipes or something like that. They can just say like, oh, well, I'm dealing with an ingredient. Let's look at ingredients.py, and like, it makes sense. So like, that was a big win. Even though this is not user-facing or anything, like, I wish that I had a way to calculate how many like spare brain cycles this has saved me personally. I think it would be impressive to see that. This is the point I'm most proud of, is because we had that JSON dump from Runscope, we actually did a full migration from Python 2.7 to Python 3.5, and changed web frameworks all at the same time, and did so with 0 regressions. And to my knowledge, we also like didn't drop any API calls. And I'm super happy with that. Like, just this slide alone is enough to like make me go, oh, I'm gonna like quit my day job and just put this on my resume. 0 regressions during update. But like that's really cool. I was very, very proud of that. I'm still very proud of that, obviously. This one was kind of cool too. Again, I don't know why this originated because we made so many big overarching changes all at the same time, but we saw a 30% decrease in average API response time, which is kind of cool. I mean, that's a substantial difference, but I mean, we're still talking like the shortest or the longest API response time that I've ever seen has been like maybe 600 milliseconds. So we're still pretty quick, but still 30% decrease. That when your graph auto scales, that's a pretty noticeable drop. So yeah, that was our experience. And I'm not saying your experience is going to be the same. Maybe yours will be a lot happier. Maybe you won't be able to put zero regressions. I would hope that you would be able to. Yeah, any questions? I was trying to double check through our commit logs to see if there were other like gotchas that people had put, you know, like do git grep or yeah, like look for swear words in commit messages and things like that. I think I hit on all the gotchas that we found. The big one was cursor.execute, and yeah, and any questions? Anything I can explain or brag about? Yes?
Do you feel like you got to your goal where you said that you don't want to be in a position where you have to rewrite it a fourth time or whatever? Do you feel like this will be good until 2020 or the sun goes dark or whatever?
Yeah, so the question was, do I feel like this refactor upgrade thing met our goals of not having to rewrite it a fourth time? You know, are we going to persist past 2020? My hope is that Barrio lives until I can retire, and I really hope that that's before 2020, but that's a different story. But yes, I think we did hit all of our goals. We have WebSocket support now, which is exciting. I'm trying to think what did I say the other goals were at the very beginning. But yeah, that's, I think we hit everything that we set out to do. Oh yeah, we also have a Python library and an SDK and an iOS SDK now. So I think it's been fairly productive. Yes? Yeah. Yeah. So the question was our source tree pretty large prior to this migration? It really wasn't. I mean, like I said, it was two files. The one, I know I could probably, actually I bet I have an early version of it somewhere on here, but I want to say it wasn't big. It was not the largest Python web app thing that I've ever made. Definitely one of the larger, but I would guess that it was probably in total around like 20,000 lines. You know, but a lot of that was just dealing with unit conversion from like weird units to weird units. You know, you talk to people who own commercial breweries and suddenly you're dealing in units that you didn't even know existed, like hogsheads and things like that. And so, it started off very big. In total, it's even bigger now because we've added other things to it, but it's broken up into manageable chunks. Before it was one giant thing and this is it, and you just need to know that, you know, that class, you know, you could search for the class definition, sure, or just know that like, oh, well, Zach wrote the ingredient or item class first because it used to track resistors, so that's probably towards the top. Like, it was unmaintainably large and interconnected like that. Yes?
You may have kind of answered this, but have you found that it's easier to add new features and do other maintenance now?
The question was, have we found that it's easier to do maintenance and add new features? And yes, very much so. Notably just because it is broken up into bite-sized chunks and it's pretty obvious where things belong. And it's really, this new architecture, file organization, whatever you want to call it, has really lent itself well to more modularization of our code base. And I think that had we not done this rewrite, there would probably still be a couple classes that are exactly the same except for one field, and now like we're doing the proper subclassing thing. There was a question somewhere, and yes?
So if you had to do it again, is there anything you'd do different?
Yeah, so if I had to do this again, what I would have done differently, when you say this, I assume you mean like the Python 2 to Python 3 migration. Okay. My tongue-in-cheek answer was I would just rewrite the whole thing in C. I'm historically a C person. So yeah, I don't know if I would have ever gone to Python from AppleSoft Basic. But with regard to Python 2 to Python 3, what could we have done different? I don't know if I can just like spout off an answer on that. I think because we met our goals of what we wanted to do, and because it was kind of like just, well, we have no idea how to get to where we even want to go. Maybe my initial, like, at the stand-up saying, hey, I'm going to get this done this weekend and impress you all on Monday, maybe I wouldn't say that, because it's always depressing to have to, like, go back and say, oh, well, actually, I can't like, forecast how long my development is going to take. I think I would be also interested in actually exploring using an ORM instead of writing our own. Maybe ORMs are polarizing features, but after monkeying around with, MySQL cursor and MySQL cursor buffered and MySQL cursor dict and all that, like I could see the benefit of just doing it once and then like, who cares about the under the hood stuff? I guess I would investigate using an ORM, but I wouldn't even know like where to begin looking for one other than going, oh, well, I know the Django ORM, but does that kind of answer your question? Okay. Yes? Yes, SQL Alchemy. Yes. Yes?
Kind of wondering about the features between Python 2.7 and 3.0.
Yes.
What was the thing that required the most coding change, either simplifying or
Yeah. So,
more work?
yeah. So between Python 2.7 and Python 3, in our code base, what required the most changes was the casting of caught errors. You used to be able to do like a try and accept block, and in your accept block guard or whatever, you could cast you do like, index error, comma, E, and it would cast your error to an index error type on the variable name E. And like I had to go in and change all those commas to as, which is super frustrating. But that was probably like the most hands-on keyboard time that required our things. A fair amount of string manipulation, just because we are dealing with user inputted ingredients. And so some of our customers that do not speak English as their first language, we, from the onset, had to deal with Unicode characters and multi-byte characters in Python 2, and then like a lot of our string manipulation code didn't work out of the box in Python 3, but that was all straightforward changes. None of those were hard changes, and like we knew from the onset that like, oh, string manipulation is drastically different in Python 3 because of the built-in Unicode support. Like, we know we're going to have to change this. So it was not a surprising amount of work. Yeah. Well, thank you, and enjoy PyOhio.